Okay, so in this video, I am actually going to give a short mini lesson or basically take some notes on vertical angles. So you can take them along with me. Vertical angles. So first we need to know what vertical angles are. I'm going to draw a picture and we're going to label that and use that in sort of our explanation here. So this, maybe I should use a different color. Let's use blue for one of these. Blue and black lines here. So vertical angles would be any angles that are across from each other, formed by the intersection of a pair of lines. So what do we know about vertical angles? Well, we know there is a theorem, and that theorem, meaning it's been proven, so theorem is something mathematically that we've been proven, we are going to say our vertical angle theorem. I am going to say the vertical angle theorem, put it here next to my picture, that and it literally is just that vertical angles are congruent. But in order to have a theorem, we actually need to prove it. So we're going to include the proof of this sort of below. So, proof. Now, this isn't going to be a formal proof, or at least a formally organized one, but it will be one that you can follow along with me and see the sort of reasoning here. So I will make, in this case, we're going to use a red line and a blue line. I'm going to label my points of intersection here. So I'll just label points of intersection. I'm going to label points on my lines A, B, C, and D. So I have line AC and line BD, and the intersection of these two is going to be in the middle here at E. So the first thing we know is that each line here makes 180 degrees. So I'm going to say that angle, and I will talk about my blue line first, so I should actually write all of this in blue. I'm going to talk about the two angles that make up the blue line. So angle AED, or the measure of angle AED. If I add that with the measure of angle AEB, that should be 180 degrees, because a line is a straight angle of 180 degrees. We just know that adding those pieces together should make 180. Likewise, for our red pieces, we are going to say angle AEB, or measure of angle AEB. So that's this one right here, AEB, and we're going to add that with BEC to say that this whole thing makes 180. So BEC equals 180 degrees. And we can say because it's a line. And that's for the same reason as above. I just didn't feel like writing the whole thing up. So we now know that they both add up to 180, but how can we prove that our vertical angles will always be congruent? So if you noticed, I used the same angle here in both explanations, or in both equations. That's AEB, because DEA plus AEB makes 180, and AEB plus BEC also makes 180. So that means the combination of those two, I'm actually going to highlight the fact that one of these is in both. That is AEB is in both of my explanations here. So that is my shared info, and I'm going to say that is this angle here. Nope, don't want a curve. I just want a straight line. And another straight line. So this angle is used in both of my explanations, and I'm going to use that to explain why my angle on the left and my angle on the right are equal to each other. So if I know these are both equal to 180, reason stands to say that I can put both of them equal to each other, that the measure of AED plus measure of angle AEB, that was my first equation, that's equal to 180. And since my other piece is also equal to 180, I should be able to say that their two are equal to each other. So measure of AEB and measure of angle BEC. We're going to subtract that common angle, the green angle, from both sides. So that's AEB. Minus measure of angle AEB from both sides to keep it consistent. What that leaves us with is just that the measure of angle AED is equal to the measure of angle BEC. And these two angles I will highlight so that we can see them easier. BEC is this angle here. That's a little too thick. This angle here. And AED, that is this angle on the left. I like color coding things because then it helps me see them in my notes if I'm looking at them again later. These are vertical angles. Therefore, vertical angles must be congruent. If we have two angles that have the same measure, we're going to use that as saying that they have, they're defined as being the same measure. So yeah, vertical angles looks like this. It is, they're either on the left or right or up and down or really just across from each other. We know they're congruent, but how can we prove it? We can use some algebra here. The last little bit I want to add on here is a way that I like to remind myself about the vertical angle theorem and how that works. And that is just a way of writing out the name vertical angles. So I like to draw my V and my A together, making that like X of vertical angles, and then just say this is vertical angles. And we can use a congruence mark to help us make the A. And we can still read it with the congruence mark on the V. Vertical angles, that's how I remember that they are congruent. We can still just put it here. And how I remember what they look like. So that is your short mini lesson on vertical angles.